Okay, so I will start again. My name is Yugi Lee. I'm professor from computer science. Today I'll talk about the human AI collaboration, especially the human side. I think I bring some of the question whether we are ready to take any solution from machine. And then the current effort for the human collaboration can apply to the human machine collaboration. That's why I see two different sides, human side and then machine side. And then we try to say that what are the technology available so far, and then what kind of potential application we can develop from this team. So today, okay. Okay. So the overall overview about my talk is to try to see the technologies for the human, not the human is for the machine AI. So whether we have a lot, what kind of issue we can think about from the AI for the human perspective. Next one is I will bring some technical issue like what are the current research from human and AI collaboration, and then especially human in the loop is some of the methodology coming from the AI and the big data and the IoT group to see what kind of the feedback we need from the human. So there's a human in the loop is the concept I want to introduce. And I want to fully focus about the kind of immersive intelligence, especially IoT is the part of the augmented reality, virtual reality technology. So I extend this IoT topic more to the augmented reality, virtual reality. Especially recently, we have a new concept coming like a digital twin. And then especially augmented reality, virtual reality, we also have like a metaverse is a new term coming from the community. So I quickly introduce this one, and then we'll discuss some of my current effort sponsored by the National Science Foundation. We are working on this immersive intelligence for the AI and human collaboration. So we'll discuss that quickly, and then I conclude my talk. So we'll see. So what's the current situation? Like how much AI can do, right? So one of the example, I think the most successful example from the AI, especially deep learning, is coming around the 2016. So that time they realized that machine can do a bit better than human performance. So if you see the human performance for the recognizing of the object like a cat or a dog or a horse, those things can be done like 80 to 90% of the 95% accuracy. But now you see that what the machine can do. We teach the machine about that this is dog, this is cat, this is horse, and then they're able to achieve about 99%, 98%, 99, reach to the perfect solution out of here. So we realize that sometimes some job machine can do better than human. Recognizing of the maybe picture, object detection, and the segmentation of some image coming from medical imaging, we can do very, very accurately to find out where is the cancer cell. Where is the brain, human brain, and then which part of the brain is some of the issue. We can do it based on deep learning technology. So point is the computer vision is one of the best area to demonstrate the AI is already make so much progress. Now, recently, we pushed this to the natural language processing, NLP technology. We have tons of documentation. Can you find that? What are the topic of this documentation? What are the emotion and the sentiments of documentation? Who's talking? How much talking? We have to analyze a lot to understand documentation. So deep learning and AI apply to this text domain and understand about the thing. Not only that, they actually apply to the video and sensor data, streaming data. They're able to detecting of the particular event, which is something suspicious, not the normal. So abnormal detection can be done based on AI and deep learning. So from this aspect, machine is not only for the particular one, they understand about a lot of data from different sources. It can be multimodal, right? So image, video, and speech, and then sensor data, streaming data, and then so that is the people can understand, but the machine can do sometimes better. That's my point. And then let's see what is the situation. And especially if you see the job market for the AI maybe how much opportunity for the AI expert to a big data opportunity or programmer opportunity from 2016 to 2025, they are projecting that opportunity is huge. The reason is that we have a lot of data coming different sources, but the human cannot do manually. So we need automation. Automation means we have to teach machine, you can do this part. because, for example, we have like a network management. We have 24 hours we have to look in for the 365 days. But the human cannot wake up and then looking for the all data and find out this is something normal, something is not normal, right? So that's why data is huge. We need automation. Some job we cannot do by human, right? So opportunity is huge, but how much the technology can support about our daily activity? That's our question. So let's keep talking, and especially job market for the the AI domain. Especially there are many different direction, but if you see 190 million dollar the thing for the 2025 they are projecting, and then new job is coming in 2025, which is 149 million jobs. So that means the new job is coming because of some changing of the technology side, and then user side, whether user is accepting this technology for daily life or not. But right now it looks like they are projecting this is huge opportunity from the AI and then big data and then IoT. Right, so especially if you see the $20 million coming from the AI, data analytics and machine learning and AI. And then beside that, we have to pay attention to privacy issue, cybersecurity issue, and the cloud issue, and software development for the application is coming. But we have to see what are the trends in terms of technology. So there's the, okay. And in terms of the area, what we have to really pay attention right now, manufacturing is one of the biggest area. They are taking the robot, like a car manufacturing system, right? They said that more than 60% or 70% of the job is handled by the machine robot arm and assemble the vehicle. And then later, a human can go and then evaluating and then inspection can be done. But some of the area is rely on the AI. We are projecting more job is coming for the AI, and AI means the automation. And then we need a robot, which is robot is not just the hardware robot. We are talking about the software robot, and then it can be helping for the daily life in our spaces. So not like a physical activity, even some mental activity or some other activity they can helping and then provide some information for us. That is what we are projecting. But about the human side, because many people worry about that, because of AI, they are losing job, right? But what I'm thinking is probably some area, okay, machine can do better. Probably they can handle this job, but the AI cannot do everything. Especially there are some of the weak in some of the area like cognitive activity, some empathy aspect, human aspect is not there yet. And then especially we need a good collaboration and the control of the machine for the human. So AI technology is not mainly for the human, right? So how to use, where to use, and when to use should be decided by the machine, the human, not by the machine. That's my point. So that's why we are projecting new job is coming, especially we are entering to the AI era, right? Timing is for the big data is available because of AI is coming to the display, play the important role for our future. So why AI and the big data are related? Why this cloud computing and then IoT is related? Because the AI is mainly based on the data. They understand data. That means they actually understand about what's going on. So knowledge can be built based on data. But data is provided by the IoT, kind of sensor and mobile devices continuously providing data. So we have to understand where this data is coming from, and then how do you understand about this data, right? And then we have to apply this to the whatever information you are getting from the data is the AI job. AI is using data to build a model and apply to some area. They can do the prediction and forecasting, and then maybe and make a decision. So important decision can be rely on some of the AI information, but human is making decision. But we need some good understanding what AI can do, right? So not only technical side, not only on human side, we need a connection between human and machine. That's why I bring this topic. It's so important because human should be ready to accept some of the AI solution. And then AI needs some human intervention and then feedback. That's why we're able to build a good collaboration between human and the machine. That's some point. So here we have some of the open question, Like what do you mean by the human AI collaboration? So far, we didn't see this one until now, right? Human collaboration. We have a lot of research coming from the social study and the education side, and the psychology. The research actually produced a good idea about the human collaboration. Now we have a new theme like human AI collaboration. This is something new area we have to really know about what is the good collaboration we can achieve through the human AI collaboration aspect. Another thing is that can you nearly use some of the what we learn from human collaboration to the AI assisted collaboration? So we are not just building from the scratch. We're going to use some of the human collaboration research to the AI assisted collaboration. Another thing is the why we do the human machine collaboration. The reason is we try to understand what are the context of the user, right? So understand the context is one of the key point to rely on the AI. AI is applied some personalized information and then decision and action for the human. So it's not the same thing. It will be different. Someone needs some help for some aspects. Other people need some other help for the other aspects. So how do you understand about the context, the key point to make a successful human AI collaboration? And now recently we have some new technology coming. It's called the digital twin. And here is mainly for human machine cooperation and collaboration. This technology is coming, so I will introduce digital twin. I think some of you already know about digital twin, but this is something we can pay attention and see, can you build a context-aware and autonomous adaptive technology through the digital twin? Is our last question I'm gonna nearly address. So first question is human language is different from machine language. And then human is using a lot of different things like facial expression, gesture, and voice, and then maybe all aspects, right? We're able to nearly understand what the human is talking to the human, or human is talking to the group. So this is the human language is definitely there and well established. Even though we have some language barrier from English to some other language, but still we have some technology can translate from one language to another language. So understand about what the person is talking. Now it's the machine side. The machine, the language is totally different from human language, right? So, but not the programming language for the machine. I think the main key point here is the interface between the human and machine. So far, everything we're doing based on typing and clicking and then some touching is possible to communicate with the machine. But we have to go beyond that. That's why we have like a speech interface. I can talk to my mobile application and then ask them to show me some information. It's possible, speech interface. Now the machine can understand about human gesture. And then we can understand about what this person is talking through the gesture, body language. And then sometimes we can build a model for the lip movement. And sometimes we understand about their EMG, EEG, which is the physiological data coming from body. Try to understand whether this person is emotionally depressed or some anxiety detection can be helping. So one of my students working on the EEG signal analysis to find out some anxiety. And then can you make it something is a relaxed through the technology? So that means machine can understand many different data. It can be text data, speech data, video data, and the sensor data, and then sound data. And then try to understand what the human is talking. Right? Even though they are not saying, still we're able to figure out what's happening. Not only that, the mobility. User is moving around and doing shopping and talking and social network. That is like a behavior, right? So we're able to get some data from many different sources and understand why we want to understand about human, because we want to help him. It's like a human needs some help for some of the emergency situation, and they need help, but then nobody can help. Then what to do? That's why some of the example, not the AI is dominate the human, but we try to make it a harmonic collaboration between human and the machine. That is the key point. And especially human in the loop is the kind of a theory coming from the AI community. So that human need rely on some of the AI, right? So AI is just a tool, but we try to find out, are there any feedback they can get from the human to AI become better? Because previously, AI is more like a black box. We don't know why they come to say this is the good time to doing something. Right? We don't know why, But because of the human in the loop, you're able to nearly hear intermediate data from the AI and then can give a feedback to the AI. This is not the right one. This is something wrong. This is something correct, right? So you can give some feedback to the AI. AI can do the better job. So it's not only for the result coming from the AI, because AI is rely on the data. So what kind of data we are pushing, and the output is always based on the data input of the data, and then quality of the output is rely on the data. So human can give some feedback in many different angles: data collection, data processing, data cleaning, and then building of the model, and using of the model, and then deploy the model. Every the direction we need a human intervention. So that's why AI can be much reliable and trust, and maybe something useful for us. That's the thing. So if you define that it's a human in the loop, that means we need some of the, so we have a different way to communicate between the machine and the human. But it's not just the one time, it's continuously learning each other and then sharing of the knowledge between them. So machine-human sharing knowledge means I understand why you are saying, and then this is what you're saying is something that doesn't make sense to me. Like a human collaboration, same thing happening here, right? So machine giving some of the information to me, but I can say this is something relevant to me, or this is something what I'm looking for. So that's why, how can you build a good the feedback channel between machine and the human, so machine can do the better job in their process. But the point is not just one time, continuously, because data is keep changing. For example, my physiological, the data is changing from yesterday to today, and then machine said that your blood pressure is too high, or your temperature is too high, or your movement is too low. Then they will say that you have to do take some exercise. That time, machine said that, oh, I want to do something else instead of exercise. That kind of the discussion going on between the AI versus the human. And then because of this one, you're able to explain about why they recommend this one. For example, the machine said that you do the more exercise, you need maybe the 10,000 steps now, but the human said that it's not a good time for me to do some of the step aspect, right? So can we explain about what they are thinking and then make it some of the harmonic communication, the decision between the human and machine? And because of this one, we need a good language, which is representation, means I understand what you're saying and I understand what you're saying. Can you represent that kind of the opinion or some of the recommendation in a certain manner? So machine understand and human understand. That means, can you build some common language between the human and machine? So this is the current work we published in the CSCW, which is the Computer Science and Social Study, the interdisciplinary research. And then this paper will be available from the ACM Human Computer Interaction in 2020. So what we did it in here is we try to demonstrate that what kind of the collaboration it can be happening between the human versus the machine. This particular example is about 311 call. We have a human representative. They are taking call from the residents. So I'm calling to reporting about the parking issue is the kind of the input from the user. And then human representative can say that, can you tell me more about the when, where, so on and so forth, right? So this is interaction going on. This is typical happening in the data collection from 311 side. But behind of this one, we also have a model available. And then based on what the human said, we're able to interpret what and why and who, where, and when, right? So to determine about this particular by machine, they are very, very good to understand. Then I am calling, and so this is a residence is calling who, and then about the parking issue, what, right? And then said yesterday is when, and where is happening, particular address is there. Based on some text, the machine can really interpret text and then try to annotate this who, what, when, where, and how is a bit tough. How and why is much tougher. So right now, this is the more like a human machine collaboration between the human representative and supporting by the robot. Robot is waiting for some of the feedback to the human representative, because sometimes the human representative cannot fully understand about what problem it is and which department can handle this problem, and then how long does it take to handle this issue, and why it is happening, and what are the follow-up activities should be done. Sometimes human representative cannot really tell to the people, so that's why machine can help to figuring out. Usually this particular problem maybe takes only maybe 1 hour or 1 day or 1 month, right? So that's why we build this kind of the robot. And another problem is the 301 call is only human is available only from 9 to 5 o'clock. Before 9, after 5, some issues coming, they are not able to talk to the human. That's why maybe human bot, the AI bot can take some of the call and then figuring out what to do. So it can be a normal, some is not urgent call like 311, but we can think about this kind of scenario from 911 situation. Somebody has an issue, right? And then there's nobody can take 911 call service are always available, but just in case they need more information, this bot can help. So this is one of the example human. We call this is the community in the loop, not only single person. This is community is reporting what their problem of the particular area in KCMO. We have a 246 neighborhood there, and each one has a different problem. So try to understand what they're talking, when it's happening, and how to do it, how long does it take, and then why this may happening, so on and so forth. So that's some of the example about the human AI collaboration in our current research. Now we want to go beyond the text, beyond the speech part, and then technology is available for the visual aspect and the virtual environment aspect. So that's the reason I bring this one is the human machine collaboration is beyond the text, beyond the speech. We have a particular platform, like a virtual platform. Human can experience of the immersive experience in the virtual scenario. It can be experienced in the real scenario, physical scenario, and then mixed reality. So if you see that this 4 different category, virtual realities we have experience in the virtual world. And the augmented reality is the kind of real, but we have a overlayered, like the object is coming. So it's something we can see that virtual over the real physical domain. So I can see some of my furniture in my room, but if you see the augmented reality technology coming, I can add some additional furniture beside my furniture. So augmented reality is somehow we are projecting a 2D, 3D component over the physical spaces. That means I can replace my furniture with something new through the augmented reality. Mixed reality is the mixed. Virtual reality, augmented reality can mix them together and can make it something more powerful to the mixed reality. But the big umbrella is the extended reality. Can you nearly make it virtual real? But this can be interchangeable anytime. And then we have some of the representation of the physical activity versus the virtual activity can connect it. And then I can go for any mode. It can be physical mode or virtual mode through the extended reality. So if you see the extended reality, right? So new term we call this the metaverse. So if you see the metaverse, we see there's some technology in this visual and virtual and reality is actually happening early 1991, right? So we have internet is available. Once they said that can you do some metaverse, like a show about some of the snow crashers or something in they introduced in 1992 and then move on. I think some of you know about the digital twin. 2020 is the early age. They actually have some vision about digital twin. I think some of you may know about the Second Life, which is the virtual world and online. And then move on. Bitcoin is 2009 and blockchain technology is 2009 and virtual reality start to use it 2011. And then NFT, which is the kind of the cryptocurrency technology, 2012. Oculus is the virtual reality devices. They still bring this one and get attention from 2014. Ethereum, which is the crypto Bitcoin technology, is introduced in 2015. move on, right? So if you see now, people nearly realize that some of the progress from the virtual reality, augmented reality, mixed reality, now we can do the something 2021. Microsoft Mesh, and then we also have like a Meta platform is coming, and people start to use the metaverse application in the day-to-day. For example, South Korea, one of my friends is teaching in the university. They already have a metaverse classroom is available, so the instructor can meet the students through the metaverse platform. That means the augmented reality, virtual reality, mixed reality is there, and then they can have a more like experience the immersive intelligence and the experience through the metaverse technology. So we have to pay attention what are the metaverse and how this will be useful for our daily life, and then what kind of research will be there is my question. So most of you know that virtual reality is the mainly for the virtual environment. I can see the virtual object, virtual avatar, and they do some activity, what we are doing in the physical domain. Like a Second Life was very popular, and then actually we build a UMKC campus on the Second Life. So I can bring all different building, and even we can show about the smart classroom in the Second Life. People can see that the virtual world in over there. And then I think another famous the virtual reality technology is the Oculus is coming. They're able to wear the glass and they can see the virtual world through this glass. That's a virtual reality. Augmented reality devices are from the virtual reality because they're able to see the real world object through the augmented reality. And they're able to projecting over the 2D or 3D object over the real world, right? So augmented reality is the more advanced than virtual reality. And so see the technology, we have a laptop and we're able to communicate with the machine through the laptop and desktop. Now we have a small device coming, smartphone and the sensor, IoT technology coming in here, right? Smartphone. And then sensor available and the mobile devices available. So we can do a lot of different data collection. Same time, they're providing good information to the user, and then some application available to looking for some information through the smartphone. But that's not good enough because it's not wearable devices. This is not, even though I forgot that I bring my phone, I cannot really use this one at all. But if we have some glass, like a glass or some wearable, some devices on the body or clothes, that means that the technology will be available, data will be available, information will be available for the people. So that's why they are pushing more to the AR, VR, and the metaverse direction. So why we have to nearly take action, pay attention to technology, especially AI, VR technology. The reason is we try to understand the context. Right? Context is the main key to find out what kind of action we can do for the people. Right? So to take some of the data from the user, we have to know about what is the motion, gesture, and body language. Is all about the motion recognition we can do. Another thing is who are the user, whether this right person to do this job, and then what's their preference, so on and so forth. This is a context about user context. And then it's the kind of the ambient speech or the audio classification. That means the data is not only from the text, it can be speech. And the sound is also coming from the body, right? So we have to pay attention about some streaming data or speech from the human as the communication tool. And then not only that, movement, like where this person is there and what kind of thing they do. So that means the personal information about activity versus location, sometimes very useful for the certain application part. Another part is computer vision or video camera. We have to nearly figuring out what are the object and what are the activity going on in the particular physical domain. Like we have some event is going, whether machine can recognize how many people is attending this event and who is participating, and then what kind of activity they are doing. We can do that through the computer AI solution that is there already. And then we have to rely on some of the cloud services because some service coming from, many services coming from cloud. So we cannot build everything from, the mobile domain or edge domain. We have to work with the cloud. So edge means the IoT. Edge means the mobile. Edge means some low-end devices. We cannot do much computing incentive job by the edge. But cloud means they have a huge storage, huge power of the computing, and then we have very, very good model over there. But we should be able to connecting between the edge to the cloud. Then we get the timely action and information can be taken by the particular situation, right? So this one is emergency situation. Probably is very useful to rely on some of the AI support. Regular activity we can do without machine, right? But the emergency situation we cannot do. No one can help me. Maybe I have to rely on some AI solution. That's why we have to see how urgent it is, how important it is, whether it's a good decision, and what other aspect I have to consider to make a decision. That's why context and anticipate need is very important to take a good action in the particular situation. And then in terms of the the IoT side and the mobile side and computing side in the user, it's pretty low end. It's very limited. They can do very minimum thing from the user side. And then out of here, we see whether we're able to extend this current technology for the mobile and desktop computing. Camera is already available. Now can you do something one level further, like augmented reality devices or virtual reality, HMD. So these are some of the example. VR HMD means a head-mounted display platform. I can wear like a Google Cardboard. I can see some of the virtual reality technology of the application from the Google Cardboard. Right. These are the example in our research lab. We are using Oculus Quest 2 as the current technology from the Oculus side. And augmented reality is the Microsoft HoloLens we are using in our research lab, and then building up some application for the augmented reality, the research. And why we have to care about the wearable glasses, right? Because there are many features already available, like camera available, speaker available, mix available, and sensor available, and then there are lighting aspect. And not only one single the camera, they also have eye tracking system and back-end tracking system, right? And then some physiological data can be added here. Like someone wants to measure about the EMG or ECG, EEG, they're able to add some additional sensor here, and then they're able to get some data from the human. So that is the kind of AR/VR thing. And then this is the kind of the revenue projection for the 3D virtual world. And especially if you see the AR/VR devices side, there's a kind of big improvement, like a $4.7 billion to $40.6 billion. That means that much attention coming. They realize that this technology may be useful for our daily life. That's why we see some changing of the revenue from 2022 to 2024. So where to use, right? So there are many applications building based on AR/VR technology now. People are using many for the travel, try looking for some new restaurant, or try to find out where's the bus stop, where's the train station, and then where's the schedule for the training. So that can be done time to time based on the way you are and what you're looking for. Sometimes a visual impairment, we need some device for someone is blind, someone cannot hear. The deaf, right? Someone cannot recognize something. Probably we need some help for someone has a disability. And then we also think about not only about the disability, but the aging is another thing. We are aging, and then our physical activity and mental activity is down now. But we also, in our research lab, we try to figuring out, can you build some AR/VR technology to make sure that aged people can exercise, mental exercise and physical exercise. So they follow some step and some exercise for the 5 minutes, even mental exercise. Can you do the memory game or some speech exercise, and then recognizing of something through our AR/VR technology. So these are the kind of a good example where to use and how to use. So in terms of application, huge. They will try to use some metaverse technology for the industry and manufacturing, healthcare, education. Yeah, education is something we are paid attention now, and we are building some AR/VR technology for the education domain through the NSF project. And we have military, definitely military. So we have to figuring out, are there any any situation we have to detecting and then respond to the particular one. Engineering and detailing and marketing and then emergency response. So I pay more attention to the emergency situation because nobody can do that, but the AI can help. Why not? We can do. Right? And then some area like a military domain, healthcare domain, they need some good information, but doctor may not have a complete information about the patient. Then AI can help to bring some information and make a good decision for the particular situation. So one of the projects we are working on is the woman clinic about the, I will show some of the project, we'll do that later. But anyway, this is kind of direction we are saying. And what I'm saying is that we are dealing with many different sensors. Each sensor will produce some meaningful information to understand what's going on. Context aware, what I say means that can I understand about the situation? But the data is coming from all different sources. Why we have to pay attention to this course? The vision is we try to understand what's going on. Especially we need a very, very good technology to fusion of the data, because one data may not be enough, right? But I may have to nearly look at the data from different sources. I have to understand. From sensor data aspect, this one looks like emergency, but the other aspect probably is not. So some of the research is how do you understand what's going on based on data coming from all different sources and all different type of data, right? So data, we don't have time to saving of data and doing something later. We have to take action quickly based on whatever we receive from sensor. So real-time process is the major key. And then there's no time to sending data to the cloud and cloud doing something and then they respond to us. That's why some technology we have to handle in the edge side, which is the mobile side or edge device side, or even the sensor level or camera level, they have to take action to taking data or not taking data, and then filtering of the data or merging of the data, cleaning of the data, and then process data minimum and try to find out this is a good thing or not. So there are huge opportunity about the multimodality and heterogeneous source and data integration, data cleaning, because the typical data coming from real world is so dirty, it's not ready to use. That's why huge opportunity there. So main goal, what I show here is that there are many data coming from different sources, but we have to go through integration of data and interpret some of the data and make a good decision based on what we learned from this data. So to this one, we cannot just do it based on the IoT, based on the maybe application by the software system. We have to bring some of the technology like AI means it's not just static model. Data is keep changing and model is keep changing, and try to find out can I understand about what's going on through my model. My models are old, then they don't understand about the new thing, right? So this is not just one time, continuously working together to build some good solution. But the data can be a visual, can be audio, data can be something else like a signal data or streaming data or video data. There are many different data coming. So can I really understand what's going on? Especially here, privacy is so important, security is so important, and trustness is so important, because how do you trust about AI's decision or AI's information, right? Somebody maybe attack poisoning of the data. Somebody attacked the model and then maybe screw up this model. This model is not working, then this data, the decision supporting is broken. So how do you trust about some data? And then okay, how much I can open? Because my data is very sensitive. I don't want to open to the people, right? So because they're collecting my behavior, my activity, my physiological data. So there are huge issue, what to protect and how much I can share. And then there's any technique I can really share without opening my sensitive information. That is another big area we have to pay attention. Okay, overall, I think I have to move quickly. So here I said that we have a lot of different applications ready, but in terms of the AI side, we have nearly built some model for motion, gesture recognition, speech recognition, and personalized interface, because each user has looking for different things. So, and then we have to see whether I can really bring some life to the object. That means the kind of the virtual reality, the real world should be merged together. Eye tracking system, and then face recognition. These are just typical things, but I see so many different recognition should be there to understand about the context in very accurate manner. So this is just subset of thing, but this is some of the important area we have to pay attention. And here are some of the example about the real world. The example is like a meeting and someone in the airport, like a current situation, someone in the, maybe in the meeting room, someone in the hotel room, someone in the house, right? But it looks like we are in the same room. We are discussing and then exchanging information. So how do you represent this, the virtual reality, augmented reality, and then we can really have a more meaningful discussion through this interaction. Not only the talk by the speaker, but we can do the interaction and question responding can be done through this ideal situation. That is the one thing. Let's go a little bit detail about the digital twin. So definition about digital twin is the real world and the virtual world. And then we have a real IoT sensor versus some of the mobile application will be there. And then that is actually tell about the human activity in physical world situation. Now, virtual world, we have that. And then they say that we have a model in the digital domain to representing of the particular user, particular activity. So that's why they say that twin. Right, so that means IoT device detail and data sync from the IoT device, data coming from IoT, and then digital twin understand about the data, and then building the model, and they are representing data through the real world, through the interaction between real world, virtual world, through the digital twin. And the application can be done through the mobile, it can be a desktop, it can be a IoT, the AR/VR technology. But this is the idea is that we have a real world, virtual world. Can you build some digital twin, which is representing me in some particular context? So then we have to teach machine. This is the me, this is my knowledge, this is my preference, this is my activity, this is my friend. They know about me. So they're able to representing me in the virtual world. So that is the concept. To build a digital twin, we have to do the data collection continuously. This is not just a one time, this is loop, data collection and data cleaning. And then out of here, we have to build a model to learn about what this data is telling us about. And then we have to take action like alert and advice based on what we learn from the data. And then we also do the make a decision and optimization of the solution through this next step. And then the next one is, can you do some of the new innovation and transformation, because this is not one time. We have to get the feedback and the machine can do better. So that innovation coming through this collaboration. So digital twin said that they will see that entire process, and then can you see make a very agile and then very effective way to connecting between real and then digital or virtual. And then from the beginning, like data collection, up to the the innovation and transformation from the existing model. So they will try a very good paradigm to connecting all together. Some of the example, right? So they said that we have a digital domain versus the real domain, especially this is a kind of factory system. And then they said that, can I build some of the real data from the real data, collecting data continuously and feeding that to the building of the model in the digital twin side. And even they can do that. Can I build the model and then can I realize that the visual representation in the virtual domain before deploy to the real world? So they use this platform as the testing, virtual testing. And then once they know that this is good, they can then deploy to the real world. Right? And then even they can say that, can I do some prediction and show the result, what's happening during the testing or during the deployment. Once you deploy that, we're able to see what's happening. And then even they say this is the easiest way, cheapest way, because we're able to see that some damage or mistake from the virtual world before you do the digital twin. That's why industry is very interesting, because this can be a saving of the effort, right? Safer and more efficient to deploy some model to the real world, because you do some virtual testing. And the data is coming from the real world to build some model in the virtual. But this interaction is continuously happening. So that's why saving of the time in development, what model we needed, and how do you know that this model may be working or not in the testing, in the virtual testing. Once deployed and then once happening, then even we can see how to handle this issue. So because of the good aspect, they said that we have a lot of advantage based on digital twin. And I think most interestingly, we have a very complex process to developing some model and then connecting to the real world. But typically what we do is we build a model and then deploy later. And we realize there are so many issues. I have to build a model again in my lab, right? And then deploy again. But this one, they said that don't do that. Don't separate this development versus deployment. They said that I want to connecting from data collection to the deployment so they can work together through the process. So like offline, right, from online versus the virtual versus physical is separate now, but they're gonna connecting together. So overall can be much efficient through the disconnection. And then these are the typical example. High technology, you have a virtual, twin, real. Construction system, we have a real versus the virtual. And then the aerospaces, like military, they have a virtual model versus a real model. They say that these are the twin from different domain. And then let me quickly go. Another example, we see that in daily life, we have an airport. It's a pretty complex system. There are a lot of things happening, but we also have digital twin available to understand how many people and what's happening, and then what are the activity going on. Is anything we need to provide some information, we're able to do that through the digital twin, because twin knows about the real, right? So but that is the key point. And then laboratory, like we do some research in the lab. I can use some of the robot arm to simulating of some behavior activity. Before you build some real thing, can you build a virtual robot, and we can do all different simulation. And then we also deploy to the real and say that this is nearly happening or not. So because this one, probably you buy some devices and realize that this is not good for your research later, right? But instead of that, can you build a digital model first? And then I can test it with some of the context. And once they know that this is good enough, then we can have a real, the system can be built for some research in the laboratory. And here, definitely medical domain. Philips have a digital twin technology. They're gonna build some digital twin for the surgery activity, like emergency room and surgery activity. And they will try to simulate some of the activity based on the human model, which is not the real in the digital domain, but representing of the patient. But the data coming from patient record, the data coming from all different devices about what's the situation in this. And then whenever they do that, decide about the surgery activity, we have to nearly know about whether this is the right way to do it, because each subject has a different situation, condition, and body structure, right? So because of that, if you know about this particular user, probably it's much good job to do the virtual surgery. So we build some of the surgery digital twin in our research with the collaboration with the UMkc Women Clinic site. If you see this video, this is from not the real surgery room, but we build some physical system to exercise about some of the activity. And they do that. And based on this kind of data, we're able to build some of the 3D model, and then augmented reality is coming, and then try to projecting of this phantom model in here. And here is the detection of some trocar, which is the trocar is this part, and then detecting of some trocar activity based on the movement. So currently we are building a digital twin for the surgery activity, and then we're going to deploy to the HoloLens devices, and doctor wearing of this HoloLens, people do some surgery, and then they able to see some invisible part, because this is the open.
Not super accurate, but does the job.
Yeah. So this is some of the not open surgery. So that's why they are not able to see the inside of the body. There are a lot of issues, bone and the bladder, and then further muscle. So they cannot touch any of them. They have to do a very good job to push these devices, which is the trocar, to some destination. So very, very accurate operation is required. But they do the exercise through the augmented reality, virtual reality. Then I think they do a better job in the actual aspect. So, okay. Another example is the CD digital twin. That means we have a 2D and 3D, the digital, the infrastructure we can see through our mobile or desktop. So why we have to nearly pay attention, because we can see the layout of the city, and planning can be done, and then some of the activity going on or some of the issue coming out, able to see through the digital twin. So digital twin will projecting of the real world to the 3D spaces, and then even they can recognize this is the some building and a car and something happening. So we have to understand about the environment of this. So this is an example about digital twin, and then we also build some our own digital twin, especially this the UMKC digital twin. You are able to see the UMKC. And here we see the home street and the Kansas City.
So I typed in UMKC on the Google Earth, and you can fly around with this using.
So this is coming from the Google Earth VR technology, but especially we extended this one to the real-time detection based on the what we are seeing from this particular augmented reality technology, virtual reality technology. So you can find a particular location. I can go to a particular area like Friedrichshain Hall. Friedrichshain Hall, we can go.
Right there. And then track down a little bit. There you go. So that's the building I'm sitting in right now. And then next one, we have Royal Hall right there. Royal Hall and Heck Hall and a bunch of buildings. So everything is pretty much rendered in 3D. I'm not really sure we can use this in projects, but we can fly around the city.
So in the scenario about this virtual reality, augmented reality with the UMKC digital twin is able to visit some particular building and then figuring out are there any issues. And the data maybe should be updated to the timeline manner.
But in order to get this Google Earth to work.
But definitely we'll have some experience, virtual experience of augmented reality or the immersive intelligence experience through this kind of technology. Right? So you're able to visit the UMKC and figuring out visit the particular building and then try to look around and then see there any activity going on. And then right now we're able to connecting to the deep learning technology to find out how many people and sitting in here and what tree, what are the load condition, what's the weather condition, all things can be detected through this technology. Okay. So because of time, I'll go to the next one. Okay. Okay, another one I want to introduce, we build some of the We Listen. We Listen is the project we did for the community. We hear about what's their problem in their neighborhood, especially we build for the vaccine project and why they have some issue and the hesitation about the vaccine. And then we conducting of the focus group is the more than 70 different the Kansas, Missouri residents, and then we hear about their voice. Where do you hear about this vaccine, and what's their hesitation, and who they trust, and what kind of thing they can improve. So we do the focus group, but we use the mobile phone to the conducting of the focus group. So we have like a speech interface, language translation, and then the text to speech available, and then privacy preserving. That means we don't know who is talking. Right? So privacy technology we provide, and then they can conducting this focus group meeting anytime, anywhere. So they can connecting and then talking. We got a very, very, very good data from the Kansas, Missouri residents, and we study about what they're talking about the vaccine hesitation part. So that is what we developed. But we also developed our PR for the We Listen. So let me show you quickly.
So I'm going to test out this room right here, focus group 4. Click join.
Yeah, to keep continue with that conversation. Hey, and you can
and that's going to take you to a room.
VR.
I haven't populated a room with people yet. I gave that task to the carrier, so you can look for some.
So you see the right hand side, you will see there's some mobile application. They are showing that this is our We Listen.
The back end stuff.
But we build a VR to represent this interaction in the VR room. Right now we have the monitor available and the screen available, and then but we don't have people yet. But this is the mimic of the real world meeting through our VR room. So this is what we are developing for the We Listen digital twin. Okay. So I think I will conclude my talk. I think I'll try to introduce about human and machine collaboration, why we need this, why we have to pay attention to this particular topic, especially it's not the individual, this is a community. And so whether we can build some culture, people can share their data, and then that data is useful for the particular action, particular decision. But without the human accepting technology, this may not be happening, right? But some people say that, oh, I don't need AI, I don't need a machine, I can do all things myself. But some people is try to open and then try to sharing of some data and then information, and even they give a feedback to the AI, and AI can do better job. But instead of the separation, I think we need the connecting together and then pay attention what we can get out of the AI and how can I work with the AI and what kind of information and then supporting can be done through the AI. And to do this one, I think we have to nearly educate ourselves whether we are open to this new requirement and new technology, because the technology is evolving so quickly. We have so many new things coming. Device, hardware, software, platform for computing and data and human requirements all changing. So I have so many issues to handle this issue, is this side, but not only technical group, but I think human side, like a social study and then some people name it, right? They are ready to take some advanced topic, advanced technology. And what is a good thing for the future? That is what I want to say. I think through this collaboration, definitely we can go break through some technology, especially some area like education domain, healthcare domain, military domain, need this AI, because we cannot projecting what will be a future. Every day, every time is everything is uncertain, right? So we are not able to make a good decision whenever we have any situation coming. So that's why let's try to open our mindset and ready to take some of the technology and advance it. But at the same time, we have to contribute and then share and the leveraging of some technology and the people side. So that's why I want to conclude my talk, and then any question, I'll take a question. I stop sharing. Yeah. Jacob, you think we can start my session if no question?
Okay. Do you hear me?
Yeah, I can hear you. I can hear you.
If there are any questions for Yugi, we probably have a very limited amount of time because we also have to have Mohammed still. So Nancy Day says, very nice presentation. Thank you very much. Anyone want to speak up needs to unmute themselves. I cannot do. Okay. If not, Yugi, thank you very much for your presentation. It went very fast and a very lot, and but it was very fascinating. Thank you very much.
Thank you so much for inviting me. Yeah.